Good good afternoon, guys. Welcome to my channel. So in this lab and lecture, we're going to understand and configure GRE at the head of this lecture. So on chapter 16 for the CCNP and Encor set guides book, so it says that overlay tunnels. So this chapter is going to cover the following subject: generic routing encapsulation, GRE tunnel. So it's gonna, explain how to configure and verify the GRE tunnels, the IPsec fundamental. This section explains IPsec fundamental and how to configure and verify the IPsec. So Cisco. Okay. Now, note, MPLS tunneling is not supporting across the internet unless it is tunneled within another tunneling protocol, such as GRE, which can be encrypted with IPsec and PLS over GRE over IPsec. A key takeaway from this is that an overlay tunnel can be built over another overlay. Now, let's go ahead. Okay, so generic routing encapsulation, GRE tunnel, is a tunneling protocol that provides connectivity to a wide variety of network layer protocols by encapsulating and forwarding packets over an IP-based network. So GRE was originally created to provide transport and non-transport routable legacy protocols such as an inter-network packets exchange, which is IPX, across an IP network, and is now more commonly used as an overlay for IPv4 and v6. So GRE tunnel have many uses. For example, they can be used to tunnel traffic through a firewall or an ACL, or to connect discontiguous networks. And they can even be used as networking duct tape for bad routing design. The most important application is that they can be used to create VPNs. When a router encapsulates a packet for a GRE tunnel, it adds a new header information known as encapsulation to the packet, which contains the remote endpoint IP address as the destination. The new IP header information allows the packet to be routed between the two tunnel endpoints without inspection of the packet's payload. After the packet reaches the remote endpoint, the GRE headers are removed, known as de-encapsulation, and the original packet is forwarded out the remote router. So we can see here, get the protocol protocol 1 is equal to ICMP, C6 is TCP, 17 is UDP. So GRE tunnels support IPv6 or IPv4 addresses as an underlay or overlay network. The following section explains the fundamental of a GRE tunnel as well as the process for configuring them. So, GRE tunnel configuration. So there go the configuration here for a GRE tunnel, show IP route, stick mode. So the steps to configuring GRE tunnel are as follows. Create the tunnel interface by using the global configuration command interface. Identify the local source of the tunnel by using the interface parameter command tunnel source and the IP address. So these are the steps. You could take a look at this yourself and just, so GRE configuration example. So problem with overlay network recursive routing and unbound. So IPsec fundamentals. So IPsec is a framework of open standard for creating highly secure virtual private network VPN using various protocol and technologies for secure communication across unsecure networks, such as the internet. IPsec tunnels provide the security services listed in table 16 and 3. So security services, peer authentication, description verifies the identity of the VPN peer through authentication. And the method used is pre-shared key, PSK, digital certificate. The data confidentiality protects data from eavesdropping attack through an encryption algorithm, change clear text into encrypted ciphertext. Data encrypted standard, which is DES, triple DES, advanced encryption standard, which is AES, and the use of DES and triple DES is not recommended. So data integrity, it's prevent man-in-the-middle attacks by ensuring that data has not been tampered with during in transit across an unsecure network, and hash message authentication. So you could take a look at this yourself and read through this, as I'm going to provide a link of this book in the bottom of this video session. So let's not take in too long here. Let's go ahead and jump in this Word document that I prepare here about the GRE. So what is GRE? So generic routing encapsulation, or GRE, is a protocol for encapsulating data packets that use one routing protocol inside the packets of another protocol. Encapsulating means wrapping one data packet within another data packet, like putting a box inside of another box. GRE is one way to set up a direct point-to-point connection across a network for the purpose of simplifying connections between separate networks. It works with a variety of network layer protocols, encapsulated packets, support packet, unsupported packets. So GRE enables the usage of protocols that are not normally supported by a network, because the packets are wrapped within another packet that to use unsupported protocol. To understand how this works, think about the difference between a car and a ferry. A car travels over a road or on land, while a ferry travels over water. A car cannot normally travel on water. However, a car can be loaded onto a ferry in order to do so. In this analogy, the type of terrain is like the network that supports certain routing protocol, and the vehicle are like the data packets. So GRE is a way to load one type of packet within another packet, another type of packet, so that the first packet can cross a network it could not normally cross. Just as one type of vehicle, the vehicle is loaded onto another type of vehicle. The ferry are supposed, in this scenario, to cross terrain, and it's otherwise could not. That otherwise could not. So for instance, suppose a company need to set up a connection between the local area network land in their two different offices, both lanes use the latest version of the Internet Protocol, IP version 6. But in order to get from one office network to another traffic, traffic must pass through a network managed by a third party, which is somewhat outdated or only supported the older IPv4 protocol. So now, with GRE, the company could send traffic through this network by encapsulating IPv6 packets with IPv4 packets. So referring back to the analogy, the IPv6 packet or the car, and the IPv4 packets or the ferry, and the third party network is the water. Now, what does GRE tunnels mean? Encapsulating packets within another packet is called tunneling. GRE tunnels are usually configured between two routers with each other. So acting like one end of the tunnel, the routers are set up to send and receive GRE packets directly to each other. Any routers in between those two routers will not open the encapsulated packets. They only reference the headers surrounding the encapsulated packet in order to forward them. So to understand why it is called tunneling, we can change the analogy slightly. If a car needs to pass from point A on one side of a mountain to point B on the other side, the most efficient way is to simply go through the mountain. However, ordinary cars are not capable of going straight through a solid walk. As a result, the car has to drive all the way through the mountain to get from point A to point B. But imagine that a tunnel was created through the mountain. Now, the car can drive straight from point A to point B, which is much faster, and it could not do without the tunnel. Now, take off point A as the network device and point B as the another network device, the mountain as the network in between the two devices, the car as the data packet that needs to go from point A to point B. Imagine this means imagine this network does not support the kind of data packets that the device at point A to point B needs to exchange. Like a car trying to go through a mountain, the data packet cannot pass through, and may need to take a much longer way around via additional networks. Now, but GRE create a virtual tunnel through the mountain needs in order to allow the data packets to pass through just as a tunnel create a way for cars to go straight through land. GRE. So guys, this is a very important analogy and illustration that we've taken and put it together for you all to understand the very concept of GRE and IPsec tunnel. So please take your time and come and take a look at this and go over different things that we may have here. And you could pause the video and look at them. Just be able to understand this very concept is very important, especially if you want to be a network engineer, if you want to work in the world of a cloud architect, you have to understand this knowledge. You have to be able to explain them to different staff and teams. So now, just for the purpose to avoid making this video super long, what I can do is I'm gonna just browse through this, and so in case if you wanna, pause the video yourself and just read them and take those knowledge and have them under your belt. Now, why don't we go ahead and pull up Packet Tracer and start doing our configuration today, which our task today, see if we could close this, close this on. Oh, that was from a previous lab. Okay, so now say and this too as well. So that was from this previous lab and lecture. So let's go ahead and close this too. Let's close that. Let's close this. And we're gonna open this now. And this was for the GRE. So let's extract. Then let's pull this and start this lab. Now the objective of this lab, let's make it quick, just to avoid wasting your time here. Okay, so let's make this juxtaposing from each other. Let's make this a little bit bigger. Let's make this a little bit bigger. Let's grab this and make this alongside to it. We have two. Let's close this one. Yeah, I want you to close just to avoid multiple there's no need to open all them. Okay guys, so I apologize for that. I should have had this spin ready already. Let's make this a little bit close like this. Yeah, make this so sorry. Okay, this just like that. Okay, so let's make this bigger. So there go the addressing table. So it says configure GRE addressing table. It gives us water one, water A and water B, PCA and PCB. So the objective is to verify water connectivity. Part one, part two is to configure GRE tunnel. Part three is to verify the PC connectivity. So now, first thing first, what do? It says so we have to use the show IP manifest is brief command. So let's go. So we have to do show IP and BR. So we gotta ping this IP. IP that we have to ping here. Okay, so this IP instead, that's this one. Now that's from PCB. We gotta do that. Let's do dang dang dang. So we gotta ping and let's paste. What do we do? So let's do about what we do here. So let's say ping. Then let's use this. Oh, so I go, what am I doing? Okay, so this, let's say bang. So this IP, that's what we have to ping. But it doesn't give it to us, so I forget. So the IP is okay, that one, that two. Let's go ahead. I got the IP, so let's grab it here. No, this one. Oh, yes. So we get a successful ping. Now, the second step after pinging PCA to PCB is pinging PCA. Let's see what's the IP for PC. It says IP config. Okay, so what's the IPv4 here? So it's this IP. See if we grab it, will it give it to us? And let's go here and let's go on command prompt, say ping. Let's see if it's gonna give it to us. Paste it, set it. The ping will fail. Right. Now the ping failed because there is no route to the destination. So now we're going to configure the tunnel 0 interface on router 1. I mean router A, which considers as router 1. So let's go ahead and do that real quick. So now we're gonna put this to enable conf t, and let's do interface tunnel 0. So now let's set the IP address as indicated in the addressing table. So it says that we got to use the IP. Tell you what, just go ahead and just grab it here, just to avoid all these hism and schism. And go up, sorry, paste, enter. Now what else we do? So we're going to set the source and the destination of the endpoint of tunnel 0. So let's go ahead and grab this, copy, let's paste it here. Now we have this, let's copy it and let's paste it here. Okay, now we got to configure the tunnel 0 to convey IP traffic over the GRE. So let's grab this, copy, move this a little bit just in case. Let's paste it and enter. Now the tunnel 0 interface should already be active. In the event that it is not, we got to treat it like any other interfaces. So go ahead and just say no shut, no shutdown. Now let's do configure the tunnel 0 on interface 2. So we're gonna repeat all these on that too. So let's go ahead and do, oh, sorry. So and conf t. Now, guys, remember, even though you don't see it, but we work with these addressing tables here. So they're going to be, so let's go ahead and do water B and FAC tunnel. So copy, let's paste it. Oh, sorry, paste. Then we do what? So we're gonna grab this IP address and make just a little change. Let's paste it. For water B, it should be that 10.2. That's what it says here on water B. 10.2. Oh, sorry. And then, as it says, a bad mask. 255.255. Oh yeah, bad mask is correct. Was removed the 2. Okay. Now we got to set the tunnel destination. You got to hit this, paste, enter, and do the tunnel destination. So the tunnel destination, water B, should not be the same as water 1. So keep that in mind. Even though that you paste this, you have to make change. Oh, sorry. The tunnel destination on water B should be this IP address is 64. Yes. So you got to understand that. You're making a tunnel for each other. Paste. Then you grab the tunnel mode. Traffic is GRE. Okay. Then no shutdown. Now, we got to establish a route between 192.168 networks using the 10.10.10.0/30. So networks are the destination. So on both of the routers, so let's go on router A to see if we have it here. We could do that. Okay, so that was pretty much very good that we don't have to type things in, because obviously it's a pain in the butt when you're trying to type all these IPs and stuff. Okay, so now it says to verify the router connectivity. So you got to ping PC. So step 1, ping PCA from PCB, PCA from PCB. Let's see. So earlier we had no ping, so now we got a ping, so we good. Then we have says trace the path from PCA to PCB. So we should do tracert. Trace the path from PC. So trace the path from PCA to PCB. So from PCA, let's do a tracert and the IP address of PCB. See what's the IP address of PCB. Let's look at it. Let's do ipconf. Up. So about ipconf. Up. So ipconfig. So this IP address, and but that was provided over here anyway. You should just grab it from here. Come on. Okay, so PCB, right? So we good. So let's do a tracert. Tracert, then paste. Now you see it says it's passed from which IP, right? So it's passed from this IP to which IP, that IP, which is the tunnel that we created to get to this IP, which is the second router. So thank you so very much, guys. I appreciate you guys was following along. That was a pretty explicit and explanatory lab. Stay focused for more labs coming up. I appreciate you guys was following along with me. So stay tuned. See you in the next lecture.